Let's get started. Hello, everyone. Welcome to another episode of the YugabyteDB Friday Tech Talks. I'm Kannan Muthukkaruppan, one of the co-founders at Yugabyte. And it's my pleasure to welcome today Fizaa Luthra from Yugabyte. I'd love for her to introduce herself and then the topic for today. Go ahead, Fizaa.
Hi, everyone. I'm Fizaa. I'm a software engineer here at Yugabyte in the core DB team. I'm specifically in the language and relational technologies team. And today I'm going to be talking about adding a column with a default value in Yugabyte. So firstly, let's sort of go over what even makes add column with the default value special, right? Let's take a step back and start with a very basic example. Assume I have a table, customers with 3 columns, ID, name, and phone number. And let's say this is what my data looks like. Like right now, I just have these 3 rows. And so let's say I want to add a balance column to my customers table that tracks the balance that all of these customers owe. And so I would just execute a simple alter table customers add column balance, and I would specify the type. So this operation is essentially a schema only change. There's no data changes or data validation involved. And the old rows are expected to return null for the new column where no value previously existed. So it's pretty straightforward, right? We don't have to change the data of the table. We just have to change its metadata. And in my customers table specifically, all the existing rows, ID 1 to 3, would return null for the balance column. And at a high level, the flow for the alter table add column involves 2 things essentially. The first is that we update the metadata on the YB master. And the second is that the master also sends a request to all the tablets present on the various servers to update their copies of the table schema. So now suppose I want to give all these customers a starting balance of 0. So I would essentially have to execute alter table customers add column balance. And here I would also have to specify a default value of 0. Syntactically, it's not very different from my first statement, right? But here semantically, the old rows are now expected to return 0 instead of null, where no value previously existed. And so a basic naive approach for this would be to do a full table rewrite and to physically go and insert the default value of 0 for all our rows. And so this would end up being a very expensive operation for very large tables. Like assume I have 1 million rows in my table, I would have to go and update each of those million rows and have the default value of 0 for all of them. Here in my customers table, I only have 3 rows, and I would expect each of these rows to have a balance value of 0. So our complications don't stop there. So if add column default is implemented as a table rewrite operation, we run into some more problems potentially. Because if the table isn't empty, add column not null also becomes an expensive operation. This is because if there is existing data in the table, then adding a new column with a not null constraint sort of necessitates also adding a default constraint, right? Otherwise, the existing rows would have a null value. So that in itself would be a constraint violation. So now just adding a simple data integrity check to a new column has become so much more expensive too. But now with the latest changes in Yugabyte, specifically to 2.19.2 onwards, firstly, we add support for the add column default operation. This wasn't previously supported. And secondly, it's implemented as a fast operation. It doesn't use table rewrite. Instead, what happens is when the operation is executed, the default value is evaluated and stored in the table metadata itself. And then...
Actually, finish this point and then I had a question. Go ahead.
Yeah, so then what happens is the missing default value is only filled in on the fly when the rows are read. So when we're reading the rows, that's when we notice the value is missing, fill it from the schema, and then relay that back to the user. Yeah. Kannan, you had a question?
Yeah, I was going to say on the first bullet where you said 219.2, we added support for adding a column with the default value. I think we had one of the things is in the older releases, ideally we should have given a notice or an error if this was attempted, but I think we had missed that case, and I believe we have taken an action item to at least backport a safety check in older releases to at least give a notice saying, hey, this is not supported, right? But with the newer releases, not only this functionality is supported, but it's cool to hear about the implementation being a fast operation. One question is other databases, let's say like Postgres, and Yugabyte is a Postgres compatible, leverages a lot of Postgres for the language layer, but Postgres has a very different storage and indexing engine than Yugabyte. So one question is, do you know if maybe how Postgres handles this case, and maybe if you're covering that, I'll just let you cover it when you come to it.
Yeah, sure. So philosophically, this approach is very similar to what Postgres does. Even Postgres doesn't always if as long as the default value is non-volatile, which I'll get into, the default value is evaluated and stored in the metadata itself. In Postgres, it's stored in the PG attribute table, and it'll just store it in the @missing val. That's the column. That's where the missing value is stored for the attribute. Yeah, and so no updates are made to the table data itself, only the table metadata essentially. And so it's kind of similar to the vanilla add column in some sense, in that it sort of behaves like a schema only change, even though from a user perspective, there are data changes. Yeah, so sort of just, so as I was mentioning before, one caveat is that this optimization only applies when the default expression is non-volatile, which basically means that the evaluated expression remains unchanged throughout the duration of the transaction. So it could be stable or immutable. Volatile default values like random are currently not supported because intuitively, if our default expression is random, then every existing row could have a different random value, right? So we would have to store all of them anyway, so we can't really leverage this fast default method. And this is again similar to Postgres, where volatile default values don't use this fast default method, and they kind of have to do a table rewrite under the hood, whereas the non-volatile ones are actually stored in the metadata. So just digging into the flow a bit deeper, let's say I insert a row into a table test with a single non-key column. And so our YSQL layer, which is our language layer and is based on Postgres, sends a request to docdb, which is our distributed storage engine, to write the row. And then we write the corresponding key value pairs to the disk. Then let's say we execute alter table add column with the default. Let's say my default expression is some foo. Then in the YSQL layer, we evaluate our expression foo. Let's say it's in constant value X. And we send a request to docdb to add this new column with the default X. And docdb stores the new metadata and the schema along with the default value X for this column that we added.
So basically, even if that shard had 10 gigabytes of data, we don't have to read any of that, write it back. It's just a metadata update.
Yes. The tablet, like the shard's metadata that's stored in Superblock, it's called, to be updated. Yeah. So now let's say I read from my table test and I do a select star from test. So at this point, YSQL would then send a read request to docdb. And then in docdb, we read from like the corresponding SSD files, and we get the value for column 1. We didn't actually store the column for value 2. So now, sorry, the value for column 2. So now at this point, we realize that we did not retrieve a value. So column 2 is missing, and we fill in the default value X. And then we return the row 1, comma X back to YSQL, and that is finally relayed back to the user.
So Fizaa, at this point, suppose I insert a new row, but this time, instead of using the default for column 2, I want to insert null for column 2. So my next insert is say 3, comma null, right?
Mm-hmm.
So now we have to store the null. We can no longer omit it, I'm guessing, because otherwise we'll incorrectly default it back to X.
Yes, exactly. So for such columns, like columns with a missing default value, any nulls that I inserted after that point are always explicitly stored.
Makes sense.
So as mentioned previously, the default value can be essentially any non-volatile expression, stable or immutable. So we can have default values for columns with different types, whether it's int type or text type, or even a user-defined type. Even user-defined types like with default values are supported. So if for my customers table, I also have a previously defined member type, I can definitely add a column with a default value of member type. And then we can also have functions as default expressions as long as they're stable. And also inbuilt functions like now, which is stable in both Postgres and Yugabyte as well. So later on, we can also change the default value of the column using alter table, alter column set default. But this operation does not affect existing rows. The new default is only for new writes to the table. So going with our customer's example, if I now set the default to -5, and then I insert a new row, the new default only applies to the new row with ID 4. The old rows will still have the old default value of 0 in their balance column. And similarly, you can re-execute the alter column set default multiple times. And this operation would always apply to any new rows that are to be written. Like this command never affects the existing rows. So now maybe moving on to a demo. Unless, are there any questions at this point or?
No, that sounds good. I'm curious, in the demo, will you also show some of the performance considerations of this feature?
Yeah, sure.
Great.
You can see my terminal. Yes.
Yeah.
Oh, sorry. So here in my local cluster, I'm just going to go ahead and create a basic table. Like just to run through a basic example first, right? Let's create this table employees with 2 columns, employee number and name. And employee number is the primary key. And then let's say I insert some data into this table of mine. Now, suppose I want to add a new column to this table, a department column with a default value of engineering. And at this point, now when I select from this table, I would expect that all the rows that I have inserted have engineering in the department column, right? So as you can see, that works as we would expect. And now let's say I want to alter the column default. Let's set it to human resources instead. And then, as I mentioned before, like alter column set default wouldn't change the default value for the existing rows. Like these existing rows are still engineering.
And that's just semantics in other relational databases too.
Yes, exactly. Yeah.
Yeah.
However, now when I insert some new rows and I select, now we can see that the new default is used for the newly inserted rows. And then we can like keep changing the default, right? and insert more rows. And yeah, the new default is always used for new rows. So then also like sort of like working through the not null problem that I mentioned earlier. If I add a column like salary with the not null constraint, it'll error out because at this point we haven't specified a default value and this is the constraint violation. But if I do not null default 100 and I select, we can see that works as well. And then, as I mentioned before, like adding a column with a volatile default value like random is currently not supported and it will error out. So that was a basic example, but now let's also sort of reason about the performance of this, right? Let's maybe just clear this out. Okay. So now I'm just going to create another table with just one column. And I'm going to insert 10,000 rows into it. And just a sanity check to ensure that we have our 10,000 rows. And now I'll switch on timing to see the performance of the operations that we execute. So suppose I did not have the add column default statement available to me. How would I go about sort of getting the same behavior, right? Basically, what I would do is I would execute add column. And then suppose I want my default value to be like, I want all the existing rows to have a value of 5. I can maybe like go back and do like a update and set all the existing rows to have a value of 5 for this new column. And this sort of gives us the same sort of behavior, right? Where now all the old rows have this value of 5 for this the new column, and I've limited it by 10 so that our terminal doesn't get flooded up. Okay. So, but now with add column default, if I do that instead, you can see that this operation is much cheaper. Like altering and then doing an update takes about 1700 milliseconds. But then adding a column with the default is only 100 milliseconds on my local cluster. And we can like sort of, using this example, we can also sort of compare the rewrite method to this fastpath method, right? Because with the rewrite, I would actually have to go and do the inserts for all these rows. So it would be in this ballpark of 1700 milliseconds. But with this fast method, it's just 100 milliseconds.
And maybe the point is that in your test case, you had 10,000 rows, but suppose you had 1 million or 1 billion rows, then one of the ways of doing it will keep increasing in time, whereas this will stay closer to 100 milliseconds because it only depends on metadata change rather than size of data.
Yes, exactly. And so then another question that we can ask is that, you know, if the reads for this column are looking into the schema, does that sort of affect the read performance of this column? So let's test that too. So let's do an aggregate on the column that we created without the default value, but actually inserted these 5s into. So that takes about 100 milliseconds. And then let's do the same thing on our column with the default value, which populates this value using the metadata. And that takes 80 milliseconds. So it's within the same ballpark.
Yeah, I guess there's some variability, maybe if we run it both a couple of times, but looks like it's in the same ballpark. Yeah.
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 So, yeah, and so this is my local cluster on my computer, right? But we can also use default values for situations like partition tables. So if I have range partition table, and I can just quickly create 2 partitions and insert 10 rows. And then we can just have like this dummy function that returns a default value. And now if I do the same alter table add column default on this, yeah, it works for the partition table as well. Like if you select from the parent table, you can see that this default value is populated for all the existing rows.
And perhaps you can show selecting from the individual partitions also, foo underscore part 1 and 2.
Yeah, so we can also select from the individual partitions as well. And that would also work as expected.
Nice.
Yeah, so I'm just gonna.
So there's a question from the audience, whether there is any limit to the number of times you can change the default value.
No, so you can keep changing the default value, like alter column set default will always affect new writes anyway. The original default that we stored, the missing value default, that is immutable. That only applies to the rows that existed before the new column was added.
And presumably, since our catalog is pretty much the same as the PG catalog, if I use a command like /d to describe the partition or the table, or a regular table or a partition table, we can see some of these default settings.
So we don't actually store it in the. Do you mean if you can see the default value from within,
like suppose you do a /d on the table foo? I'm curious to see what it will show. So okay, it is showing the default as function foo part now.
Mm-hmm.
Yeah, basically because of our catalog is PG compatible, and operations like /d under the covers issue catalog queries to learn more about what the table is and pretty print that information. It is working the way you would expect in PostgreSQL itself, right? And you had other examples, other tables, like what was your previous table name? Yeah, test with update. We could probably just do a /d on. Yeah, and we see the default. Yeah.
Okay, sorry, I'm just going to. Yeah, so those were the examples, and then so just some additional notes. Like, do we always rely on, one question that we can ask is, do we always rely on the metadata for the column value, right? The answer is no. The missing default value is actually backfilled for the existing rows in some cases. The first one is when there's a table rewrite operation that is performed. For instance, alter type with on-disk changes and changing the primary key of the table. These are some that we support. And this is again philosophically similar to Postgres. Postgres also uses table rewrite as an opportunity to actually write the missing default values. And then also during compaction, when using the packed row storage format specifically. Yeah, and I've linked the tech talks on compactions and packed storage format in these slides if you guys want to check it out.
Another question coming in is, when adding a column with default, is the performance the same whether you specify it as not null or allowing it to be nullable? Is there a difference?
No.
Yeah, okay. So you're saying there's no performance difference, it is the same. Yeah, that makes sense. In both cases, the intent is recorded in the metadata, right? And for new rows coming in, if you have a not null constraint, then that's validated as well, right? So yeah.
And for the operation itself, the not null validity can just be performed in the default expression itself. Like you don't have to check the existing rows, right? So
that's correct. Remind me, I mean, I know if you add a primary key to the table and all that, we do implement the table rewrite operation because we have to change the way the data is clustered on disk. Are there other alter type operations that we are supporting already with on disk changes? Like suppose I would imagine that if I change the type of a column from a varchar of size 10 to varchar of size 20, that's probably just a metadata only operation. We don't need to do any changes. But if I change the type from, say, integer to float or something like a computed expression, are we already supporting some of those operations today?
Yes, so alter type with on-disk changes is also supported now. I think even that's 2.19.2, but I might be wrong about the exact release. But yes, we do support alter type, which requires a rewrite now.
And does that mean support for things like default random is in the near horizon? Are you going to talk about some of the future plans with?
Yes. So yeah, in terms of future work, we will eventually support add column with volatile default values, but this would, of course, involve a full table rewrite.
Makes sense. Wonderful. Yeah, and thanks for covering an excellent topic on time. Sometimes we can go a little bit over time. And thanks to the audience for their questions and for joining us. Please join us again for another topic next week. And if I recall correctly, it's about, some work that's gone into the product to help connection ramp up and reduce your first query latency. As suppose your app is like scaling up a number of connections to the database. Usually there's a warm-up phase where the connections are issuing lots of queries and preparing their statements and so on. So a bunch of optimizations around catalog caching are coming into the product, and we'll be talking about that next week. So thank you, everybody. Have a great weekend, and over to you, Fizaa, for any closing comments.
Yeah, no, thank you so much for joining me in this tech talk. Yeah, have a great day, everyone.
All right, see you all.